Good day, grade 12 learners. Welcome to today's subject lesson. My name is Jabu Sitole. The lesson is broadcast or brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Today, grade 12, we are going to look at momentum. The last lesson we dealt with Newton's laws and forces. Today it's momentum. Now it's momentum, change in momentum, and impulse. Before we can go further discussing the topic, it is very imperative for us to look at the exam guideline. The extract that we have is from the exam guideline. Now, the topic that we are dealing with today is from mechanics. Mechanics comprises of forces, Newton's laws, comprises of momentum, which is the topic that we are going to deal with, then comprises with wave, sound, and light, comprises with, wave, sound, and light is its own, but it comprises of work, power, and energy. So those are the topics for the mechanics. And then if we check in mechanics, mechanics has 93 marks of the paper. Then it tells that mechanics contribute more marks in when it comes to the final year question paper. And then the percentage thereof is 62%. Now, the total mark of the paper is 150 marks. So this is very important. So in other words, the chapters that we are dealing with, they are the build up of these 93 marks. These are the raw marks. Then the percentages is 62. So it is very important that we know this extract of the exam guideline. Now, as I said last week, this extract, I will ask educators just to print it and then give it to you and paste it at the back of your book. All the time refer to it so that you understand each topic. It's the build up of the knowledge area of content. So the first topic was forces and Newton. Then the second topic that we are dealing with today is momentum. So they are within the content mechanics, and the marks thereof is 93 and the percentage thereof is 62. Now the total mark of the paper, because the paper will be comprises of what? Of mechanics, electricity and magnetism, and wave, sound, and light. So that makes what? The composition of the paper. Right. Let us move to today's topic. Now, to start off, I want to build this lesson with the framework. We've got the framework that is momentum and impulse. Now, what does it entail? Now, momentum, if we deal with momentum, we know what we should know its definition. Remember, I said definition, it's two or nothing. So either you get two or you get nothing. So we must know what is momentum. So we must know how to define momentum so that we can get that 2 marks. So the definition thereof will define momentum, but now I'm giving a scanty picture of what we are going to deal with as we are having this framework. Now we are dealing with momentum. This is our momentum. And then the definition thereof as object is the momentum of an object is the product of mass and velocity. That is the definition of momentum. We are going to talk about it as we are moving along. But we need to know what is the definition. Now, we are talking about linear momentum. We're talking about the momentum, the motion in a straight line. So, what we are going to talk about again is that momentum, as we are defining it as a product of mass and velocity, it must have, the mass must have the SI unit, and velocity must have a SI unit as well. We will talk about those SI unit. The momentum has what? The formula. As we are going to calculate, we use formula to calculate. So momentum, the definition that we have defined there builds into what? It builds into the formula that we are going to use to calculate momentum. Then these are the things that you need to grasp and put it in your mind as I'm speaking with momentum. Now, momentum of an object depends on, I said it, it's two quantities. It's a mass, it's a velocity. So this thing, it guides you. The framework guides you as we move along. You know, I want you to grasp so that when we just start unpacking, you know exactly, this is said it as we are unpacking. Now, we talked about momentum. We have defined momentum. What we are going to talk about as well is a change in momentum. Right? What is change in momentum? Is the difference between the final velocity and the initial velocity. That is the change in momentum. And what we are going to look at in change in momentum is that it is a vector quantity. We know that the vector quantity must have what? A magnitude and the direction. That is a vector quantity. Then the same change in momentum is going to give us a formula that we are going to use to calculate the change in momentum. Therefore, it must have what? The SI unit. So this is the SI unit that we are going to talk about as we are going to build on the calculations of the change in momentum. So these are the formulae for the change in momentum that we are going to use when we calculate the change in momentum. Then we go to the next one. We are going to take further the momentum in terms of Newton's second law, because it's going to help us when we discuss momentum, how momentum in real life happens. So this law, second law, is not the second law that we used last week when we state Newton's second law, but it's second law in terms of what? Momentum, linear momentum. So there is a difference between the two. So we know how to state the Newton second law in terms of linear momentum. All right. Then it's going to give us the formula as well that we will be using to calculate the force or the net force in terms of Newton's second law. Then we'll go to impulse. We'll talk about impulse and we'll define what impulse is. And then we will take the examples of how an impulse apply in a technology, or how impulse apply in a real life. So we'll be talking about that. And then we'll end that the lesson there. Then we'll continue when we continue dealing with the types of collision. For today, we are anticipating to end our lesson in impulse. Then the next lesson will be going through the types of collisions and the calculations thereof. So I believe that as I'm giving you the scanty framework, you're now starting to picture, you're starting now to have something in your mind. Okay, momentum must have this, momentum must do this. So how to calculate momentum? So it's going to come at least handy for you, and as we unpacking the lessons. Now, I want to take this scenario with you so that we understand the background of momentum. The scenario says a bullet, I'm going to talk about a bullet when fired, as small as it is, it will do more damage than a brick if the brick was thrown. That's strange. Remember, a brick, we are thinking of a huge thing. A bullet is just a tiny little thing. So now we have a huge brick and the tiny little thing we call the bullet. But when the bullet is fired, it can kill. But when the brick is thrown, it cannot kill you, maybe. For now, let us put it like that. It can just cause injury. But now, what is happening is that when both the bullet and the brick were fired or thrown at the same speed, the brick can cause damage because they move at the same speed. Right? When the bullet and the brick were thrown and fired at the same. Now, what does that tell us? It tells us the mass does not matter. The mass of the two does not matter. But what matters is the speed at which the two objects are traveling. That is what matters. Now, it says here, so how does happen that the lighter object does damage than the heavier object? Now, I said to you, the impact is going to be, it does not depend on the mass alone. Let me put it. Yes, the mass is there, but it does not depend on the mass alone. It should depend on what? On the speed. So, the speed is the one that causes. Now, therefore, the two, the mass and the speed, if you multiply them, they'll give you what? The momentum. Remember, we are saying the mass and the velocity are the product. So, of momentum. Momentum is the product of the two. When you multiply them, they give you what? Momentum. So now, that comes now with the background of momentum. That comes now how momentum it's happening. Now, it says, therefore, momentum has two quantities, which is a mass and velocity. Now, if you multiply a mass by velocity, then what do you get? A momentum. So this is what we have here as a formula. This is the definition. The definition of momentum is defined as a product. In mathematics, when we talk about products, what comes to our mind comes multiplication. So it's a product of an object's mass and velocity. So in other words, you are having P, right? Let me just write it in this space. We are having P equals to, P denotes what? Momentum. We denote momentum, or we represent momentum as P. So P is equals to a mass multiplied by, which is the product, velocity. Now, velocity, it's a vector. It must have what? Both direction, magnitude and direction. Even though we talk about momentum, it is a vector. We denote a vector with an arrow. Now, a vector means magnitude and direction. So, this is momentum. Now, this momentum, having a mass and having a velocity, it gives us an equation or a formula. Sorry, this is the formula that we are going to use to calculate momentum. And you'll find this formula in your data sheet. I'll show you as we move along. Now, to calculate momentum, we always say, for us to calculate, we must have one unknown and the other knowns. It can be two knowns, right? Depending on the number of knowns that you have. But you have one unknown and two knowns. Now, in other words, if they say to us, let us calculate momentum, for an example, they are giving us a mass of 20 kg, and they are giving us the velocity of 2 meters per second, then we will be able to calculate momentum, because we will multiply the mass with the velocity, then we get momentum. However, as we calculate or do calculations, at the end, we need to have what? The SI unit. We must know what is an SI unit of momentum. Now, we know for the fact the SI unit of a mass is kg, kilogram. This is kilogram, kg. And multiply by the SI unit of velocity, it's meters per second. This is meters per second. Then we write meters per second. Then what does it tell? What is an SI unit of momentum, therefore? Then it will be equals to kilogram meters per second. This is the SI unit for momentum. So in other words, we'll be using this SI unit at the end when we find the answer or we find the magnitude. So remember, if you don't write the SI unit, you will be penalized. So it's very imperative, learners, that you write the SI unit at the end of your calculations, and you know very well what are the calculations. So you don't have to cram it. You must know which quantities are you dealing with, so that they will give you the SI unit. So we say that the momentum acts in the same direction as the object's velocity. So if the object moves in a right direction, so your momentum will move in a right direction. Now, this is what I want you to know as we are going to deal with the momentum. These are the tip or the calculations of momentum. Read the scenario carefully and underline keywords or collect the given data. It's very important. Read the scenario you are given carefully and do the underlining. Now, if you are given, for an example, a car of a mass of 100 gram, underline that gram, 100 gram, you are giving 100 G. Underline as you read along. Is traveling at a velocity of, let us say, 20 meters per second. Underline the 20 meters per second. This is what is giving you the collection of the data that you are going to use. In other words, what you have, so that you can see what is it that you don't have, because you must calculate what you don't have. So collect your data as you move along. So it's very important. Read your scenario. Reading is very important, but you read it carefully. Then you underline. This is very important. You underline as you read along. Then you collect the given data. That will help you. Now, remember, if we talk about momentum, we've got velocity. This is velocity, V. Then this represents momentum, P. Then this one, it's a change in momentum. Change in momentum. And we've got the average force. All are vectors. So all these are vectors. They've got magnitude, and direction. So once you start calculating momentum, you must think of what? Must think of direction at the end. Right. Always take direction into account. That's what I'm saying. So you must take direction into account because you are dealing with what? You are dealing with vectors. So once you deal with vectors, you must take direction into account. Read to the data sheet when carrying out calculation. Learners, you are given a data sheet at the back of your question paper. Familiarize yourself with the data sheets, all the formula that are there in your data sheet. It can be equation, can be formulas, but familiarize yourself which formula are they looking for to calculate what you want to calculate. So in other words, go at the back. As we have your data, we have collected your data. Now your data will show you what is it that you need to calculate, or its momentum. Okay, now what is the formula for momentum? What comes to mind? Momentum must start with P. So we are looking at anything that it says P equals to mv multiplied by mv. Now it means you are collecting the data. First, you cannot calculate without a formula. There are learners who are just taking values there and multiplying and come up with the answer. Remember, we must know what is it that you are calculating. So start with a formula. It's simple. Don't invent the wheel. The wheel is already there. Take the formula there you are given as it is, then you plug your formula, then you plug the values that you are given. Then you come up with an answer and the direction. Now, pay attention to the marks. Pay attention to the marks. If it's 3 marks, know where are you going to get 3 marks. 3 marks, they want the formula, they want substitution, then the answer. That is 3 marks. 4 marks, the steps will show. Maybe 1 for a formula, 2 for substitution, and then the answer and the direction. So it gives you how many marks it's given there. Remember, marks are not there as a statue. They are not there just for fun. They are there for a purpose. They may say time, or they may guide you as to what to do. That is very important with the marks that you are looking at the end, even at the side of the paper. Let me put it that way. Now, this is the data formula, the data sheet or a formula sheet that I'm talking about. Now, if you look at the formula sheet, this has been extracted from the data sheet that we are using at the end of the year, or at the back of the question paper, or to our exam guideline. Now, these formulas we dealt with last week. These ones. These are for force or the loss. So these are formula that we dealt with last. So these are for the forces. But for today, the formula that we are dealing with is this one, momentum. It's going to help us when we calculate momentum, because you go there and look for the formula. Then I see. P equals to mv. That is momentum when they want you to calculate momentum. We are going to deal with the formula for impulse, which is net force change in time equals to change in momentum. And then we are going to deal with the formula for change in momentum. So these are the formula for today that we need to know in terms of the formula sheet. So it's very critical, it's very important that you know the formulas in a data sheet. And learners, don't come up with your formula that we don't know. Formulas are there, you are given. Copy a formula as it is, as you are given. There is no way where you want to modify the formula. Don't modify it. Take it, plug the numbers that you are given, or the values that you are given, or the quantities that you are given, and then come up with an answer. Simple and straightforward. Don't make life difficult for yourself. All right. Now, let's go to work example. This is a work example. We want now to apply what we have learned in terms of momentum. Now, it says to us, determine the momentum. Now, the momentum, that is the first thing that we are told to do. Of what? Of mass kg, 6 kg, of an object moving at 5 meters per second to the right. Now we are giving what? We are giving the direction. Remember, momentum has to have a direction. Now, I've underlined, isn't it so? Do you see, as I'm reading, I'm underlining so that I understand what I am talking about, or I am collecting the data that I've been given. So the data that I've been given is that, one, I must determine momentum. In other words, they want me to calculate, or they want us to calculate momentum. Determine, they want us to calculate, right? Momentum of the mass of 6 kg, 6 kilogram of an object moving at 5 meters per second to the right. Right. Now, I said it and I'm still saying it to you. Go to your data sheet. We go back to a data sheet. We look at what we want. We want a formula that has a mass. We want a formula that has a velocity. That is what we want. So we need to have a formula that has a mass and a formula that has a velocity. That is for momentum, because we are calculating what? Momentum. Let us go and look. We don't want this. It does not speak to what we want. We don't want this one. It does not speak to what we want. This one, it has momentum, but this momentum is a change in momentum. They never talk about change in momentum there. They never even talk about the force, the net force, or a time. So we don't use that one. This one is a change in momentum as well. But they never say anything about change in momentum. Right? Gravitational force. No, I don't remember that they are talking about gravitational force. All right? It falls off. Then this one is for a force, the frictional kinetic friction. They said anything about kinetic friction. So we are left with only one. Let us check it. P equals to mv. Or P, it's for momentum, equals to m for a mass, v for velocity. I think this one is the correct one. It's the one that we are looking for. All right. Now we know for the fact that we are looking for P equals to mv. Now we are given the mass. Now the mass that we are given is 6 multiplied by, now we are given 5. And now, can we take our calculators? You know, we can take things for granted and then we say 6 times 5, we know what is it. And then you'll be surprised when you mark the answer is wrong, because learners, they use their head. I know we are mathematics. You do mathematics. You are a mathematician. Let me put it that way. And you do mathematics. But let us verify. It's better to be safe, learners, than you regret at the end. Then you, just because now we are nervous, you are writing, you'll give the answer that your mind tells you. Now, I want us to verify, to make it our responsibility to have a calculator. We brought the calculator for a use, not just for a fun. Now, one may say, We can just calculate, use a calculator 6 times 5. Yes, it's very important for verification. If you are sharp, then do it your own way. But I want us to do it for the benefit of those who want to verify. Now we have 5 multiplied by 6, or 6 multiplied by 5. All right. Now, in my calculator, it gives me 30. All right. Now, then we write, it gives me 30. This is 30. Now, I have 30. Now, I got the answer. Hooray! I'm correct. I'm okay. I have 1 mark there. I picked up the correct formula. Then I've substituted there according to my data. Then I have the answer. Then I'm done. Remember, we said it. At the end of your calculations, you need to have SI unit. All right? You need to have SI unit. If you don't have SI unit, you leave it like that, then it's going to be 2 out of 3. You'll be penalized. So please, learners, be careful. SI unit are very important. They are telling us as to what is it that you are calculating. Remember, as I was calculating moving on my left-hand side, I was not writing P. All right. Now, but your answer will tell me exactly what is it that you are calculating. Now, we said mass, the SI unit for mass is what? It's kg. Then the SI unit of the velocity, we said, is meters per second. That is the answer. This is correct. But one thing left. I'm in error. Why now? One thing left. Remember, this is a vector. We are given a direction, but they said to the right. So we have given a magnitude. Where is the direction? So you must write the direction to the right. That is how you do it. Now I want us to qualify, therefore, that we have done a correct one. Right? The answer is correct and our steps are correct. Now this is the answer. This is what we wrote. Hurrah, it's correct. So we've got the formula, we've got the multiplication, which is 6 times 5. Then we've got the answer, which is 30 kilogram meters per second to the right. So we are still moving in a correct space. Now, number 2, work example number 2. I love it. It says a car has a momentum. A car has a momentum. We are given a momentum of what value? Of 20,000 kilogram meters per second. We are given a momentum in this regard. Now they want us to calculate, what? Calculate the car's new momentum. How can it be? We are given a momentum. Why they want us to calculate a momentum? Because already they are giving us a momentum. But now they are saying if its velocity double, yes, we are given a momentum. But now the momentum when the velocity is double, how are we going to do that? Because for us to calculate momentum, we must have the mass and we must have the velocity. But they don't talk about the mass here. Now you start giving up and say, this is difficult. Then we need to think. We need to come out of the box, and then we think and we use our knowledge in terms of if they are saying double, what they mean to us. They are saying the velocity here is twice, isn't it? It's twice v. Okay. Now, what is that is going to help us then for? What is going to help us is the formula. Remember, they want us to calculate what? Momentum. So we need to go back to the formula for momentum, which is P equals to mv. This is what we know from the data sheet. But now, if you look at this formula, we are told that we have this mass, but our V is double to V. That is what we know. Yeah? Now it's clicking, right? Now, what we know further, we know that for us to calculate momentum, we must go back to what? M times V. All right? Now, if we take the 2 out, then we'll have mv. Then we have momentum here. This is our momentum. All right? Now, in other words, what comes to our mind is that this momentum that they are talking about is this momentum. This is this momentum. We'll substitute it there. Voila. Now, we are having 2 multiplied by 20,000. What does it give us? I know they've already have the answer in their head. I still say, for verification, use a calculator. Because exam cause anxiety. We want to write fast and then do fast. I know the answer there is 40,000. Bruh. But let us verify it. Do it with a calculator. Now, we have the calculator. We say 2 multiplied by 20, 0, 0, 0. Then it gives us 40, 0, 0, 0. Right. Now, this is the momentum that they want, because we're calculating momentum. Right? Now, I want to emphasize this. You can't leave your answer without SI unit. You can't. So this is going to be kilogram meters per second. This is your answer. It's very important. And then where does it go? In the direction of your velocity. All right? Because it's what? It's a vector quantity. Now, let us verify that we've done a correct thing. Voila, here it is. We have done a correct thing. They got their answers as 40,000 kilogram meters per second. Now, what does it tell? It tells that the first momentum that you are given is going to be doubled. So it has doubled, because they said velocity is doubled. So the momentum is what? Doubled as well. You started with 20,000, now you came to 40,000. So it is double. All right. So this is very important. This is how we calculate momentum. And remember, it's very important to understand. The jigs here, learners, is to understand. When you read with understanding. Hence, I said it in the tips that I gave to read the scenario with understanding. Draw some line while you are reading and capture the data. It's very important, right? Now, this is the third example, because I want us to do this example. We still have time. We'll do example and then we move on to explain. All right. Now, they say calculate velocity. Now they want velocity. These people. It's nice, eh? Calculate velocity of the car if its momentum, now we are giving again momentum, is 6,000 kilogram meters per second. And the mass, we are giving the mass here of 2,000. So you collect the data as we are moving along. But now, remember, they are not looking for momentum. You are given momentum. Now they are twisting things. Even if they want momentum, look for the formula that has if they want velocity, giving momentum. Look for the formula that have velocity. And then, as I'm going to do this, I will appeal with you, learners, very appealing, to say, if we use the formula P equals to mv, we are told that we have momentum. We are given, this is momentum, we are given a mass, this is a mass. Then what do we want? A velocity. I'm appealing to you. Don't do a subject of the formula. If you don't know it, don't do it. Because you'll swap things where it shouldn't be. Then you lose marks. Please, use the formula as it is. And do your mathematics as you know it. Then you'll get the answer. Take it each step at a time. Don't rush. The changing of the formula is for those who can be able to do it. But for us, let us take things steady by steady, steady by steady. Now, what am I saying here? We are given the velocity of 60,000. Sorry, the momentum of 60,000. Sorry for that. The momentum of 60,000. Now, the momentum here is 60. This is momentum. It's coming this side. 60, 0, 0, 0. All right? Now, equals to, we are given what? The mass of what? Of 2,000. All right? Then multiply by what we don't know. Use it as it is. Don't rush. Don't rush. We have done the substitution. I'm afraid if you just swap things, you may lose somewhere. Then you lose the marks. Right? Now, what do we know? 2,000 multiplied by V is 2,000 V. Right? So it's going to be 2,000 V. Now, we don't want 2,000 V. We want V. So we need to divide with what we don't want. I repeat, we need to divide with what we don't want. This side. We only want V this side. Right? Now, in other words, here is going to be 2,000. What you do on the left-hand side, you do it on the right-hand side as well. So you divide with 2,000. Then the 2,000 cancel it out. Now you are left with what here? With V, which is V equals to. Now you do your mathematics now. 60,000 divided by 2,000. We go to the calculator. I'm not intelligent. I want to do things correctly. Then it's 2,000. All right, so let us go. We're going to move faster a bit. Now it's 60, 0, 0, 0, divide by 2, 0, 0, 0. For me, it gives me, what you got? For me, it gives me 30. So I have 30, right? 30. Now, we are not finished. What is an SI unit of the velocity? Remember, the SI unit for momentum is kilogram meters per second. Now, for the mass is kilogram. Now, but here, there's one that we are short with is what? Meters per second. Meters per second. All right. I've done the examples. This example that I'm going to come up with now, it's a challenging one, but it's not a challenge in such a way that you cannot do it. It's a challenge because it wants to convert this. Remember the conversion, learners, from grade 10, we started with conversion. So you cannot calculate with kilometers per hour. You cannot. So it's very important that you change this. Now, how do we calculate the next one? We'll verify them thereafter. Now, I always say to learners, they want us to calculate momentum. We are given this, right? I'll do my own to say P equals to mv is what they want us to calculate. However, we have this one, which is the mass, and we have the velocity, but our velocity is in kilometers per hour. Now, what we do, I want us to do it like this. We say we have the mass, which is 90. Now, kilometer, what's that? Does it mean? Kilo. Kilo means multiply by what? 1,000. Right. Multiply by 1,000. Per means divide. That's per. But now the hour, what makes an hour? It's 60 times 60. Which is, if we multiply this, we are going to get 3,600. Then you can start calculating to get your final answer. All right. So this is how we do it. So I do it step by step so that it may take you through and see how best can we do it. I substituted the mass, which is the mass. But now our velocity, it has kilometers per hour. This is our velo. We take it in as our speed. But now, this one, it's 1,000 kilometer. Then I multiply the 90 by the 1,000. Then I divide, because it's per 60 by 60, which is, it gives us 3,600. And then we multiply. If we multiply it, we get the answer. Now I want to move fast. This is the verification of the number 1. This is the verification, which is 25 meters per second. All right. So here there is a bit of SI unit. So the SI unit for momentum, because sorry, we are calculating momentum, it's supposed to be, kilometers per second. All right. That is momentum, because they say calculate the momentum. So we're calculating the momentum, right? So we'll verify this. The final SI unit is kilometers per second. That is the correct one. Due east, because we are giving the direction of due east. Right. Now let us move faster now. We're dealing with calculations. I think now you have a view as to what are the calculations. Now, change in momentum. We said change in momentum is the difference between the final velocity and the initial velocity. That is change in momentum. And change in momentum depends on the what? The change in velocity. And then the SI unit for change in momentum, as I alluded in our sketch there, or our framework, we said is kilogram meters per second. R is the same as what? Is the same as momentum. Now, change in momentum, as we were saying, is the difference between the two. This is the difference. The final velocity minus initial velocity. This is the formula that you are going to use when we calculate change in momentum. Now, the work example. They say a soccer ball have a mass of this 500 gram and is kicked at what? At 12 meters per second towards the wall. It goes towards the wall. And then it bounces off the wall at 2 meters per second. Calculate the change in momentum. Now, there's a directions that we need to take cognizance of. One, here we need to change the mass. We don't calculate using grams. We always calculate using kilograms. Now, we said kilo means what? 1,000. Now, in other words, we are going to divide your 500 with what? 1,000, right? In other words, we are going to say 500 divided by 1,000 to get the correct mass. That will give you what? The kilogram, right? Now, if we start now calculating. If we say 500, let me do it faster with you. 500 divided by 1,000. We know that is going to give you 0.5. 0.5, right? We know that is going to give you 0.5 kg. That is your mass that you're going to use. Right. Now, calculation. How do you calculate a change in momentum? Remember, it's not now we are not calculating a momentum. We calculate a change in momentum. Right. Now, the same ball has the same mass. The mass doesn't change. Now, is delta P equals to M for a mass, is the mass of the ball. Now, a bracket. Now you have V minus V bracket. Now, what are these V? The first V is for the final velocity. The second V is for the initial velocity. Let us go back. The final velocity, this is it. The initial velocity. This is what I'm talking about here. All right. Now, how do we calculate then? We must take direction into cognizance. They say the ball is kicked towards the wall. 12. Kicked towards. It's an initial. The first velocity is the velocity that is moving towards the wall. And then it is a positive one because it's moving towards the wall. Then the term rebounds. It rebounds, it comes back. In other words, it hit the wall, it rebounds, it's coming back, then it's going to be minus because it's a motion that is coming back, right? Now, in other words, our 12 there is going to be minus, our 2 is going to be minus, our 12 is going to be the positive. Then let us substitute. We know that this one we have converted to 0.5 bracket. This one is minus 2 minus plus 12. Plus 12. Then you may do the calculations thereof. Then you get your answer. Then, in other words, if you multiply a negative and a positive, you get what? A negative. So you're going to get negative 12, right? This is going to be 0.5 negative, multiply by negative, this is 12. Then 12 plus 2 is going to be 14. All right? Then you may start calculating then, right? Then if we calculate, we say we multiply now. 0.5 multiplied by negative 14. It gives you negative 7. What are we calculating? Kilogram meters per second. But the direction, we cannot leave there at minus. We must say 7 kilogram meters per second. Then we give the direction in an opposite direction or away from the wall, because we change this minus, we say it there, away from the wall or in an opposite direction. So that is how we calculate. This is it's how we calculate it. We have verified. Then it's away from the wall. So the minus there tells you don't leave it there. This is mathematics. You say it scientifically what is happening. So scientifically, this is what is happening. Right. I think this is how you understand. Now, this is how we are going to test yourself. I'm not going to do this one. I want you to copy this and test yourself. You are going to test yourself, test your knowledge on what we have done. All right? We've done so many things. So these are the calculations, are the kinds of calculations that supplement what we have done so far. Now, question 1, you have a mass. Then you have got a velocity. You've got another velocity. They want you to calculate the change in momentum. So this is what I want you to do. You can do it now, you can do it at home, but I want you to do this because you are testing the knowledge that have you grasped what we were doing or talking about. All right. Question 2, you've got the mass of an object. Slow down. We've got an initial velocity of 40 meters per second. They give you a direction west. Then we've got the velocity to west again. Then they want you to calculate the change in momentum. So this is what you're going to do. This is how you test your knowledge. So your teachers will be giving you time to do this one. I'm assessing whether have you grasped what we were talking about in terms of the change in momentum. All right. Let's go to Newton's second law in terms of momentum. Know how to state the law. It's very important. Know how to state. All right. This is Newton in terms of momentum. Not Newton's second law. Remember, we started with Newton's second law. Now we are in terms of momentum. What does it say? It says a net force or a resultant force. Remember, net force, all the forces that are acting together, or the sum of forces that are acting together, acting on an object is equal to the rate of change of momentum of an object in a direction of momentum. A rate of change of momentum. Now, what does the term rate mean? The term rate, it denotes time. All right? It denotes time. Now, in other words, net force, this is net force. It's equals to the rate of change. The rate of change. This is the rate of change of what? Change in momentum. So, it gives you the formula. This formula is net force equals to delta P. We know delta P. What does it mean, delta P? It's a change in momentum over delta T, which is the rate. All right? This is the formula we are going to talk about. It's going to help you in terms of when we come to the practicality of applying the law. All right? Now, what is very important? This law, we are going to use it when we calculate one, the increase in the direction of the motion. That one we are talking about the rocket engine, right? Then the decrease when we apply the brakes, when we talk about the decrease. Then the reverse in motion, e.g. when the ball is hit against the wall and then it comes back. So it applies in this, in terms of calculation. And then the net force act on an object is the same is in the same direction as the change in momentum. This is very important. So once you apply the force, the same force is in the same direction as the change in momentum. Know this, learners. It's very important. All right. Now, impulse. What is impulse? Impulse is the product. Remember, we said momentum is a product. Impulse is a product of the net force acting on an object, right? And time. That the net force acts on an object. In other words, if we talk about net force, the impulse, we are talking about this. This is the impulse. We are talking about the net force. This is the net force that is acting on an object, and the time that is acting, the force acting on an object. This is the impulse. Now, when learners are asked what is an impulse, they will say impulse is equals to change in momentum. That is not the definition of impulse. That we call it the impulse momentum theorem. We are not asked about the impulse momentum theorem. You are asked to define an impulse. Define an impulse as the net force, net is very important, net force acting on an object, and time, the force acting on an object. That is an impulse. This is an impulse. Right. Yes, impulse is equals to. Yes, impulse is equals to change in momentum. That is a theorem. It's not a definition. You'll use that one when we calculate. And remember, where does this come from? This comes from the formula, the past one, net force equals to change in P equals to change in T. We have made a subject of the formula, the P. Then in other words, you are going to multiply by the change in time. Even this side, we multiply by a change in time. Then in other words, this one is going to cancel this one. Then this side will be having net force multiplied by change in time, which are the two. This side will be remaining with change in P, which is this one. So it comes from there, right? Now, net force acting on an object is equals to the rate of change in time, is what the definition says, the definition of impulse says. Now, net force is the rate of change of momentum, all right? Net force is the rate. We said net force is the rate of change in momentum of an object. Now, this says this. And we know this comes from Newton's second law in terms of momentum, right? What is it that we must know about an impulse? One, impulse is a vector quantity and it has a unit. When has a unit, it means we are going to do calculations. Now, the SI unit of an impulse is Newton second. In other words, remember, we've got a net force. We've got a change in time. What is the unit of a force? It's Newton. What is the unit of time? It's a second. That's why we've got Newton second. We get it from here, the SI unit. So you must not forget about that, right? You must not forget. You know that this is going to be your time, right? So note now, I've put the note in red. Note that when calculating change in momentum, the SI unit for change in momentum would be those of momentum. In other words, the SI unit of a change in momentum, we know, is what we know. And the SI unit of momentum is what we know. What are they? Let's start with momentum. Momentum is kilogram meters per second. Now, the statement says the SI unit of change in momentum must be those of momentum. If for momentum is kilogram meters per second, therefore, even change in momentum must be kilogram meters per second, is what they are saying. Now, impulse will have the same value as object change in momentum. In other words, what they are saying, impulse, if we are talking about impulse, if we calculate impulse, is going to have the same value. Let us say our impulse is 40. Then it's going to have the same value as what? The change in momentum. The change in momentum is going to be 40. What's going to differ then? What's going to differ then is SI unit. We know the SI unit from there is kilogram meters per second, is what they said, which is change in momentum. But we are told, remember, the SI unit of the impulse is Newton meter. Newton second. So they might have the same value, but they will differ with what? SI unit. So it's very important when you calculate. Right. Note as well that the force acting over the very short space of time that the force is acting over the short space of time, period of time. In other words, the force that is acting it's acting just a very short period of time, So that's one. For an example, when the tennis hits the wall, it will be in contact with the wall for a very short period of time. That doesn't mean bam, then it just stay there and then no, it's just a short. It's going to be a contact, yes, but a very short period of time. Then start bouncing back, right? Work example. Now this work example is for the impulse. Now we are given that a golf ball with a mass of 0.1 kg is driven from a tee. This is the tee. This is the tee. And this is the golf club. This is the golf. Right? Now the golf ball experiences a force. We're given a force of 1,000 Newton while it's in contact with the golf club. All right, this is a golf club, and then moves away from the golf club at this velocity, moving away. Right, now calculate the time. They want us to calculate time during which the golf club was in contact with the ball. They want time. Now, for us to calculate time, we need to go back to the formula net force equals to change in time. Then we must be given what? The change in momentum. Right. Now, we know for the fact that we are given the force. Now we have the force. Now we want time is what we don't know. Now, what is a change in momentum? We know that change in momentum is going to be mv final minus vi. All right? And then this, if it tells, and then if it shows, it tells you that the force that we are giving is going to be 1,000 here, multiplied by what? A time that we don't know. Now, here we are given as what? Our mass of the ball is given as what? As 0.1 bracket. Then here comes the thing now. What is our final velocity? What is our initial velocity? Let us read. The golf experiences a force of this while is in contact with the club and move away from the golf club at this. It's moving away. In other words, this one is a velocity whilst there was a first velocity, there was it moving away now. In other words, the initial velocity, the ball there, it was standing, was having no movement. That is going to initially, there were no movement initially, right? Then we've got initial velocity, then the final velocity. Now, in other words, our initial velocity, v1, it's equals to 0 because there's no motion. Therefore, it means our final velocity, this one is going to be vf. This is going to be the final velocity. All right. So now you can calculate. Then you can say this is 30 minus 0 because this is 0. Then you start calculating. But now what do you want? You want the t. All right. Because of time, I'm going to give you the answer. This is what I was saying to you. So we've got this one. This is what we have. We've got this one. This is what we have. Then your answer is when you calculate for t. Remember, your answer is going to be what? Your answer is going to be in seconds because you're calculating what? Time, right? So this is in second, right? Right. Work example 2. Now, my take here, or what I want to drive home, is that the reading of a scenario, understanding of a scenario, all right? Calculation, they will come. We'll do calculation, but you need to understand the scenario. You are given the mass. This is the mass of the basketball. The mass is 0.53 kilogram. Hits at the wall head on with the forward speed of this. You are given the speed. This is the forward speed. In other words, the initial speed, which is 18 meters per second. And then it is rebounces. That's the weights. All the weights, they give you meaning. It rebounces. Now, I said immediately when it rebounces, it getting back. Now, in other words, your velocity, the other velocity, the final velocity will be minus. So this one, the velocity here will be minus this velocity. And then we are having a contact time. We are given time. So what comes to your mind? They may say to you, calculate the force if you have a contact time. Remember, the other side we were given force. They wanted us to calculate time. So this time they're giving time. They may say calculate force and calculate the impulse, right? Now, for us to calculate the impulse, it's easy. Impulse, I'm not going to calculate. I'll give you the answer. I want just to show. Then impulse, we said impulse is net force delta t equals to change in P. This is what we need to know, learners. This is what you need to know. Now, we are calculating this. We are calculating the impulse. This is the impulse. They say calculate, determine the impulse of the force. Now, the impulse. They are not calculating the force, right? Not yet. They want you to calculate the impulse. Now, you know that you need to change this one. This 2m bracket, v final minus vi initial. Then in other words, they want you to calculate the change in momentum so that you get the impulse, right? Now you substitute. This is your substitution, your values to substitute. Then you get your impulse, right? Then after you shall have calculated the impulse, they want you to calculate what? To determine the force. Now, because they are giving you what? They gave you the time. Then you can calculate the force. Because the time that you are given here, it can help you to calculate the force after you shall have calculated what? The impulse, right? So, this is what is happening. We have calculated the impulse. These are the values given and the mass given. Then this is the formula to calculate impulse. Then this is the force given. This is the initial final velocity. This is an initial velocity. Then you can calculate your impulse. This is your value of the impulse. And we said the SI unit for impulse is what? Newton second. All right. Okay, learners, are with me? Do you see how to calculate the impulse? Then let's move the second one to calculate the force. Remember I said to calculate for the force, you've got net force equals to, net force change in time equals to the change in momentum. Now, we want the force, all right? The force is what we want, the net force. But we are given time. What is time? We're given as 0,1, right? Our time is 0,1. So here we've got 0,1. Here we already calculated the impulse. It gives us 16. All right. Sorry. All right. It gives us right 16,695. This is what we have calculated, right? We already calculated, of which we said it's when we go to original, it's minus there. All right. Now you divide by 0,1, you divide by 0,1. 0,1 cancel out. Then you are left with net force equals 2. Then you start now calculating. Then you get the answer. So probably if you calculate fasting, it's going to be 16,695 divide by 0,1. Then it gives me 166,95. What is the SI unit of a force? It's Newton. All right. So we are moving with time. So in fact it's supposed to be minus because we have that minus. We are taking the original, right? Remember, we are not taking the final answer. Let me go back a bit. We are not taking the final answer that we got is this one, right? We're taking, but if we don't leave it at that, we just speak to it, right? But now if you start calculating, we're taking the final answer with the minus. Hence we have our answer as minus there. All right. Right. This is the question again that you are going to take and then test your knowledge. Remember, we teach and assess. We teach and assess. This is your assessment. You test your knowledge based on what we have done. So here, we are given the mass of this, and we are given what? Kilometers per hour. I did that one. You must do the conversion. You must do the conversion, learners. So the 72, you must convert it to kilometers. To meters per second. So from kilometers per hour to meters per second. So I did that example on how to go about to change or to maneuver to change or convert the kilometers per hour to meters per second. Now we are given even time there. It means once they are giving you time, what comes into your mind is that there may be a possibility that they want you to calculate a force, right? Because you are given time, right? If you are given a force, there might be a possibility that they want you to calculate what? Time. So you must play around with this, read with understanding. So they want you to calculate the initial velocity of, calculate the initial momentum of the car. The initial momentum of the car. Then they want you to calculate the final momentum of the car. They want you to calculate the change in momentum of the car. And then remember I said once there's a time there, they will want you to calculate the force because there's time. Right. This is the work that you need to test yourself. I was going to give you a second or two to do it, but I want you to do it at home. Then to just apply whatever the steps that we have put in place, then see as to can you get the marks. All right. Now, quickly, application of impulse and change in momentum. Momentum and change in momentum. Now, how do impulse, momentum, and change in momentum applied? Or where is it applied? One, use of the airbags. The use of the airbags. Here's the picture. When the car collides, then the airbags helps. But how? Now they say when the airbags is inflate, when the airbag inflates during the collision, the contact time, this is very important. That's why I've made it bold and I've made it red and I underline it. The contact time of the passenger or a driver with an airbag, it's longer. Now the others, they say longer, the others they say increase. So the contact time increase with the airbag. Without an airbag, a contact time of a driver. Now, of the passenger or a driver with an airbag is longer. Then is what I said, it increased. Without an airbag, while the change in momentum remained the same, thus the force, that is it, the force of the passenger or a driver reduced. What do you mean by reduced? It decreased. If the contact time increased, the force reduced. It's very important. Right? So this prevents what? Injuries in the car. That's why they put the airbag. It prevents, it minimizes the force. It minimizes the force for you that we are going to have contact time with the steering wheel. So the force will be minimal, but the contact time will be longer. In other words, once you hit the airbag, your time with the airbag is going to be longer, but the force is going to what? To be reduced, or it's going to increase. Hence, we have this, remember, in terms of Newton's second law. Crumble zone. The cars nowadays, they use a crumble zone. Let me put there. This car in front here has a crumble zone to prevent injuries when it hits or it collides with another car. So that is a crumble. It has a crumble zone. Every day accidents take place on the roads of our country. Modern cars have a crumble zone to reduce the risk of death or injury during collisions. So the crumble zone reduces the risk of death or the injuries. So you must remember that. But you will not say, if they say, what is the use of the crumble zone? Then you put that it's increased death and injuries. No. We'll talk about it. Now, what does it do? When a car crumbles during the collision with the other car, if there is a collision between two cars, what is happening? The time of contact, remember what I said, the other one, the time of contact, the contact time, right, between the objects and the car increase. Do you see? It takes longer. It increases. While the change in momentum of a car remains the same. The change in momentum of it doesn't change, it remains the same. But you look at the two things. You look at the time of contact, which is what? Which increases. But what does the force? The force, this effect, the force does what? Decrease. So it decreases. All right. Now, what I want to bring to you, or your attention, then, as you will be asked this question, but you must know that if we talk about the time in contact, right? This is the time in contact. Then you must know that there will be an increase of the time in contact, and there will be a decrease in what? In a force. That is very important. So if you want to remember, you use this formula. Remember, I'm keeping with this formula. I'm giving you this formula, or this law. Let me say this law of momentum in terms of Newton's second law. Right. Now let's go to seatbelt. Seatbelt, we're familiar with. You come inside the car, you must fasten the seatbelt. Immediately when you come inside the car, you fasten your seatbelt. Now, the same thing, whether it's seatbelt, whether it's crumble, whether it's the airbag, same answer applies. Whether it's yes, Aristobate, because they should be for Aristobate. I didn't put Aristobate, but the same answer will be the same. Is the increase in contact time and the decrease in what? The decrease in force. That is all that you need to give answer to. When there is a contact, then the contact time, it becomes longer, or it increases. But what happened to a change in momentum? It stays the same. And then what happens to a force? It decreases. That is very important. Then that's what you need to understand. And what I mean, these three applications, they are very important. Airbag, crumble zone, seat belt. The fourth one is Aristobate. I didn't put Aristobate, but the teachers will allude. But the application there is the same. The increase of a contact time, the change in momentum remain the same, and then the seat belt, it's the force decrease. These are the long questions. I'm not going to dwell with it, but these are the long questions coming from the question paper that you need to deal about. Now they want you to calculate momentum. To define momentum is 2 or nothing. We define momentum. Write down the magnitude of the initial velocity, or of initial momentum. Now, in terms of this, you've got a block and the bullet. When the bullet travels there, it's going to penetrate the block, and then they move off together. Now, what is the initial momentum of the block? The initial momentum is going to be 0 because there's no movement. That's why it's 1 mark. That's why I said look at the marks. Look at the marks. Then calculate the magnitude of momentum. All right, before. Then 3 marks. 1 mark for this. Then substitution. Then the answer. 3 marks. All right. Then it's long questions is what you're going to do. 6 marks. They want to define impulse. We've defined impulse. What is an impulse? Calculate the force. Remember, once you see time, once they mention time, what comes to your mind? You need to calculate force. Once you see force, you need to calculate time. That's how you read it. So here they want you to define the impulse. Then they want you to calculate the force because they've given you the time. All right. Now, these are just long questions. I'm just giving you the schedule as to how are you going to calculate them. This is our last question, and then our lesson's over. I'm not going to do it. This is from the extract. It's an extract from the paper, right? It's an extract from the paper that was written in 2019. The first metric for technical science wrote this, right? Now, if you read this, it gives you the object mass, the baseball, the mass is thrown, then it gives you the velocity, then it comes back, it gives you, is like rebounds, right? At this velocity. Then this is going to be your VI, this is going to be your VF, right? Then you start calculation. Then they say define 2 marks. Now, here they say you need to choose between increase, decrease, and remain the same. Read the question with understanding. Read it with understanding. If they want, you read with understanding. Don't just pick. Right. Whatever that we said, then it tells you. Then read. So it says, how will the impulse of the ball on the bat be affected when the velocity at which the ball returns towards the thrower is increased to a value greater than this. Increase to a value greater than this. So what is going to happen? The impulse is going to increase, isn't it? So I don't know why it's going to be increased because it's returning. It cannot move the same as it was, right? Now, then these are the questions following the other questions. Then this is the question that I want you just to think about. Then we are done. I'm not going to do 3.1.4. I'm going to talk about 3.1.3. Will the force exerted by the ball on the bat increase, decrease when the time of contact, I love this, of contact of the ball on the bat increase? Give reason for your answer. Assume that your change in momentum remain constant. Remember when we talk about the application of the ball. So you know when the time of contact increase, what does it happen in the random. Now, learners, this was the last slide, and this was the end of our lesson. We thank you so much for watching the lesson. I believe and trust that you've gained a lot in terms of momentum. Go and try those knowledge questions, then they will help you. Thank you so much for watching this lesson. Please remember to sanitize, wear your mask, maintain a social distance, keep safe. Thank you so much.